Hello, Algebra 2 student, and welcome to this lesson on operations with radicals, part 1. In this lesson, you'll be provided with some examples, again, thanks to the people at All Things Algebra, which imply adding, subtracting, and multiplying with radicals. Okay, so again, thank you to All Things Algebra for providing the problems that you're about to see. Okay, so first we are going to do adding and subtracting radicals. So one thing to keep in mind as we add and subtract radicals is that it's just like adding and subtracting with variables. You just want to make sure that you're combining with like terms. Okay, so keep that in mind as we start doing some problems here. So let's begin. All right, so here's our first problem. Again, this is from All Things Algebra. We have this situation here. We have 3 cube root of 54 minus 2 cube root of 2 plus 7 cube root of negative 16. Now, as we see here, all these have cube roots, so there's a good possibility that we can eventually add or subtract these combined like terms because they all have the same root. Now, what we have to do first, of course, is that we see a negative on the end. It says negative 16. We have a cube root and you have a negative inside. That basically means that you can take that negative out. So what I'm going to do is I'm just going to rewrite this as the following. For now, it's going to be 3, then cube root of 54 minus 2, then cube root of 2. And then because it's a negative 16 inside of a cube root, we can change this plus sign to a minus, and it'll be negative or minus 7 cube root of 16. Okay, so anytime there's a cube root or any kind of odd number root, you can take that negative out and everything's going to be okay with that, writing like that. Now, the next thing we'll do is we'll go ahead and simplify the radicals that we can. So we'll do that, of course, by using a factor tree. So we'll start with 54. And so when we do 54, we'll do that right here. So for 54, we can break that down in a certain way. Let's do 2 and 27. Then we got 27 can be broken down to 3 and 9, 3 times 9. And of course, 9 is 3 times 3. Well, because we're looking for a cube root, since our index is 3, I'll go and write that over here. That means that we can go ahead and write down, or we can circle, I should say, a group of these group of 3s. So let's go ahead and circle this group of 3s right here. And then the 2 is box because it's untrioed, I guess, so to speak. It can't be grouped. So then what I do here is I'm going to bring down 3 cube root of 54. Just going to drop down the cube root of 54, cube root sign, excuse me. 2 is inside the box. So therefore, we're going to put a 2 on the outside or on the inside. And then we have a 3 already outside, but we also have this group of 3s that becomes 1, 3. So it becomes 3 times 3. Okay. So we'll deal with that in just a moment. Now, as far as the next term, it says minus 2 cube root of 2. You can already tell, hopefully, that 2, the only way to get 2 is 1 times 2 when it comes to whole numbers. So we're just going to just drop that down. So we'll have minus 2 cube root of 2, okay? Then for this one, we have minus 7 cube root of 16. So we'll go ahead and do a factor tree for that. So let's do a 16 factor tree. So we got, let's see, 2 times 8. 8 is 2 times 4. 4 is 2 times 2. And again, we're looking for a group of 3 numbers, and we do have that. So let's go ahead and circle that group of 3, group of 2. So we're going to group that, circle that group, and then we'll put a box around the 2. So then, once again, we'll just come down here. We'll write minus. We'll write our cube root over here. Once again, 2 is going to be on the inside because it's boxed. On the outside, we already had a 7, well, negative 7 basically, and we have a group of 2s. So we'll put times 2, okay? All right, so now the next thing we'll do is we'll simplify this a little further. So we're going to have 3 times 3. So 3 times 3, of course, is going to be 9. So it'll be 9 cube root of 2. Then it's going to be minus 2 cube root of 2. And then the last one is minus 14 cube root of 2. And then as you can see, all of them end with the cube root of 2. So therefore, we can combine these. We can add them together. So basically what that means is we have, if I do it this way, it'd be 9 minus 2 minus 14. And then all that is the cube root of 2. So then that just means that we just subtract 9 by 2 and then subtract it by 14. So 9 minus 2 is 7. 7 minus 14 is negative 7. So therefore, the solution to this will be negative 7 cube root of 2. And that is the answer to this problem. All right, so for problem number 2, we have 10 square root of 28 plus the cube root of negative 56 minus 4 square root of 175. Now, in this particular case, we do not have common roots. I mean, we do have two terms that have square root, but the other term has a cube root. So we will need to still simplify this because there's still a possibility that we could perhaps combine the square roots. Now, the first thing I do, though, is since I do have a cube root in the problem with a negative number inside, I can go ahead and rewrite the problem like this. It'll be 10 square root of 28, and then it's going to be minus cube root of 56, and then minus 4 square root of 175. Okay, so again, with a negative inside of a cube root, you can take that negative out, and it'll work out the same. So now what we got to do is simplify all three of these terms. So we'll start with the square root of 28. So what we'll do first is we'll just do a factor tree for 28. So let's see how we can do 28. We could do 2 times 14. We could do 2 times 7. Okay, and that's it. And because it's square root of 28, it's a square root, all you gotta do is look for a group of, we'll put index right here. All you gotta do is look for a group of a pair. We just have to look for a pair, and we do have a pair. So we're gonna circle this pair of 2's, and we're gonna put a box around the 7. So that means for 10 square root of 28, we're gonna go and write the square root right here. We see a 7 that's boxed, that's gonna go on the inside. Then we had 10 already outside, multiplied by the 2 that we just got from the factor tree. So right now we have 10 times 2 and square root of 7. The next thing we'll do now is do the cube root of 56. Well, the cube root of 56 means that we have an index of 3, and that means I'm going to now do a factor tree for 56. So we're going to have 2 times 28. We're going to have 2 times 14 for 28. Then we have 2 times 7 for 14. Now, since the index is 3, that means we're now looking for a trio or a group of 3, and we do have a group of 3. We have that group of 2's. So we're going to circle the group of 2's, and we'll put a box again around the 7. So now we're going to write minus. Then we'll bring down the cube root, because that's what the index we're doing with. 7 is going to go on the inside because it's boxed. And then we have a group of 2's with nothing else already outside except that minus. So therefore, just put a 2 on the outside. Then we have the next one, which is the square root of 175. So again, that index is going to be 2. So we're going to simplify the square root of 175. So we'll have 175. So that means we're going to have, we're going to break this up. Let's see how we can break it up. Well, we could do, let's do 5 and 35. Okay. Then the next one for 35 is going to be 5 and 7. So again, this is a square root. So we're just looking for a pair. That means we're just going to circle the pair of 5's that we have here. So we'll circle those and put a box around the 7. So now all we have to do is write our minus sign, because that's what we had to begin with. Then we write a square root. 7, again, goes on the inside because that's what's boxed. We already had a 4 outside, a negative 4 already outside, and a 5 from the group of 5's. So therefore, we're going to have negative 4 times 5 on the outside. All right, now we're ready to simplify. So we have 10 times 2 on the outside for the first term. So that's going to give us 20. So we're going to have 20 square root of 7. Then minus, we still have 2 cube root of 7. And then we have 4 times 5, minus 4 times 5, which will be minus 20 square root of 7. Now, you'll notice that all the radicands basically are 7. Okay, remember the radicand is the number inside of a radical sign. But remember that only 2 of these are like terms because we have square roots, and the other one is a cube root. So what we have to do here is we're only going to combine this and this because, again, they both have just square roots. Well, that's 20 square root of 7 minus 20 square root of 7. Well, 20 square root of 7 minus 20 square root of 7 is going to be 0. It's going to cancel out. So I'm going to go ahead and just cancel these out. And all I have left is just negative 2 cube root of 7. And that is the answer to this problem. All right, here's our third problem with adding and subtracting radicals. So this time we have the square root of 98 x to the power of 4, y to the power of 2, and then minus 3x to the power of 2, y, and then square root of 2. So once again, what we're going to do is we're going to try to simplify any radicals we can, and then maybe perhaps combine the like terms. Well, in the first term, we have that square root of 98 x to the fourth y to the power 2. So we're going to first start off, of course, by trying to simplify the 98, the actual number. So once again, we do know that we don't have any other radicals but square root. So we'll go ahead and write that the index is 2. So let's take the 98 and we're going to break it up. How do we break it up? Well, let's see. One way we could do it is we could do 2 times 49. And then for 49, it's 7 times 7. And so therefore, we can circle that group of sevens. It's a pair because the index is 2. That's all we're looking for. And then we'll put a box around the 2. So we got that taken care of. Well, I guess we can go ahead and just write our square root right here. And we can go ahead and put down that 2 goes inside the radical sign. And then 7 is going to be written on the outside. So we'll put that over here because remember, we also have these variables. Now, as you may recall, whenever you have variables with a radical sign or inside of a radical sign, what you'll do is you'll take the index and you'll take the index and you'll basically divide the exponent that you see for that variable by that index. So for the first one we have is x to the power of 4. So basically for x to the power of 4, that's basically saying we're taking the 4, the exponent, and dividing it by 2, the index. Well, 4 divided by 2, or 2 goes into 4 twice with no remainder. So 2 remainder 0. We'll do the same thing for y squared. Y squared means we're taking the exponent 2 and dividing it by the index, which is also 2. And 2 into 2 is going to be 1 with a remainder of 0. Okay? What that basically means now is that since the x went in twice, that means that we're going to write on the outside of the square root here 7x squared, okay, because it went in twice. And then for y squared, it went in one time, so we just write the y on the outside as well. There's no variables to write inside because we had no remainder. So right now we have 7x squared y, then square root of 2, that we simplify for this first term. Now we're just going to bring down the other term because we have nothing to simplify because it's just the square root of 2. So it's going to be minus 3x squared y square root of 2. Now, if you look very carefully, we see that both terms have a square root of 2. So that means potentially we could combine like terms, but we could further confirm that we can combine like terms because on the outside of both of these terms, we have an x squared y. Okay, they're both x squared y. And since they're both x squared y, that means that these are both like terms. And so basically what we're going to do at this point is basically just take the 7 and subtract it by 3 because they both end with x squared y square root of 2. They both end the same way. So therefore, basically it's going to look like this. We'll just write it like this: 7 minus 3, and then it says x squared y square root of 2. Okay, because again, those are like terms. And so if I combine 7 minus 3, then of course that's going to be 4. So therefore it's going to be, I'll write it right here, 4, and then x squared y, and then square root of 2. And then therefore that is our simplified answer for this problem. All right, so now we're on to multiplying radicals. And so multiplying radicals basically goes through the rule of this. Basically, if you have an index with something in it, okay, and then you have the same index with something in it like that, then basically what you can do is the answer to this would basically be that it would be that same index and then A times B. Okay, so as long as they have the same index, you can multiply the radicands together. And then once you've done that, you can simplify and then go from there. Okay, so that's basically the kind of the rule that we're going to be using over the next few problems we're about to show you. Okay, so without further ado, let's get on to some examples on multiplying radicals. All right, for our first problem here, we have 3 square root of 10 times negative 2 square root of 18. So as you can see, both each index that you see, the indices are the same. So we know that the index here is going to be 2. So we can write that now. And now we're just going to multiply these together. Now, basically, the rule basically says is that if they're the same radical, have the same index, they can multiply. That also works for the inside or for the outside as well. Basically, we're just going to multiply outside to outside, inside to inside. That's basically how it works. So first we have 3 times 2, basically, excuse me, 3 times negative 2. Let me undo that. So it should be 3 times negative 2, if I can get this erased, but maybe it's not going to work for me. Okay, let's try it again. There we go. So 3 times negative 2, so we got that. And then we also multiply the square root of 10 to the square root of 18. Okay, so we just basically multiply the outsides together, multiply the insides together. Well, we have 3 times negative 2. So 3 times negative 2 is going to be negative 6. Okay, then we have the square root of 10 times square root of 18. So that's going to leave you with a square root of 180. Okay, because 10 times 18 is 180. So now, just like before, we're just going to try to simplify the radical. So we'll just do a factor tree for 180. So let me come over here, since I got a little room, and do the factor tree for 180. Well, let's see what we can do here. Let's do, well, we could simply just do 10 and 18 like we just did. So let's do that. So we got 10 and 18. For 10, we could do 5 times 2, okay? Hopefully you know why I'm doing it that way instead of another way. But we got that. And then 18 is going to be 2 times 9, okay? And then for 9, we could break it up as 3 times 3, okay? So with that being said, what we can do now is circle any groups that we have. Again, the index is 2, so we're just looking for pairs. So we do have a pair. In fact, we have 2 pairs. We have a pair of 3s right here, and we also have a pair of 2s right here. The 5 that was not broken up will get boxed. And so now we'll come back over here to the problem. We're going to write our square root symbol. We have a 5 that's inside a box, so we'll just put 5 on the inside. Then we have a negative 6 already outside, and we got a group of 2s and a group of 3s. So therefore, those are going to go on the outside, be multiplied to that negative 6. So we have negative 6 times 2 times 3, and then the square root of 5. So now we're just going to multiply negative 6, 2, and 3. So negative 6 times 2 is negative 12. Negative 12 times 3 is negative 36. So therefore, it's going to be negative 36 and then square root of 5. And then there is our solution to this problem. All right, so here's our next problem. We have negative 3 and then the 4th root of 64 times negative the 4th root of 8. So as you can see, each of the radicals have the same index. So we can go ahead and write down that the index for this problem is 4, okay? And because they are the same, that just means that we can go ahead and multiply outside to outside and inside to inside. Well, we have negative 3 on the outside of the first part, and then just a negative on the outside of the second part. So negative 3 times a negative, basically, which is basically like a negative 1, is going to be positive 3. So we're going to have positive 3, and then we're going to have the 4th root of 64 times 8, okay? So now we're going to multiply 64 times 8. So 64 times 8 is going to be 512. Okay. All right. So I've looked at this before. I'm not using a calculator. I just did this all beforehand. So now we have 3 times the 4th root of 512. So now at this point, we are going to go and do a factor tree for 512. And let's see if we can get something here going. So for 512, one thing you could do is you could do 4 times 128, okay? Then for 128, you could do 4 times 32. Then for 32, you could do 4 times 8. And then for 8, you could do 4 times 2, okay? Now, of course, if you did not realize that, then of course you could just broken up by 2s. but I kind of knew what was going on. So you always want to try to find something that you could, maybe easily break up, okay, without, too much trouble. But as you can see, that since the index is 4, we were looking for a group of 4s, a quartet, okay, quadruplets, whatever you want to call it, okay. And we do have a group of 4s. So we're going to go ahead and circle. Uh-oh, I didn't mean to do the eraser there. Okay, can I undo? Yeah, okay. So we're going to, like I said, circle the group of 4s. So we're going to do that right now. And we're going to put a box around the 2 because it's not in the quartet. So now we're going to come back over here to the problem. We're going to rewrite our fourth root in this case. And because the 2's in the box, we're going to put a 2 on the inside. And then on the outside, we have the 3 already there times 4, okay? Because 4 was the group that we found. And so all we got to do, of course, is multiply 3 times 4 on the outside, and that's going to give me 12. So it'll be 12 and then the fourth root of 2. And that is our solution to this problem, our simplified answer. All right, so here we are now with number 6. So our 6th problem of the video, not necessarily number 6 on the packet or whatever, but just number 6 in our video here. You see here that we have a cube root for both parts. So therefore, we know that the index is going to be 3. And we also see that we have variables to deal with. So we'll deal with that as well. So obviously, since the index for each part is the same, we are going to multiply the insides together. And let's remind you about variables because I'm not sure, at least at this point, we haven't talked about this in a regular school year. Here being, December the 1st, can't be it's December, okay, 2025. So what we're going to do here is I'm going to basically take I'm just going to write the cube root, and I'm going to multiply -3 times 36, okay? Then I also have a to the power 7 times a to the 6, and then we got times b to the power of 4 times b to the power 2, okay? So now multiplying the numbers, of course, shouldn't be too much of an issue. We're just gonna rewrite this now as the cube root of negative 108. That's what -3 times 36 is. Now, remember when it comes to variables, when you're multiplying with exponents, that you just need to add the exponents. Okay, so that's the rule. When you are multiplying with exponents, you add them. Okay, so just to remind you, a to the power m times a to the power of n. Two different exponents. Just means you're doing a to the m plus n. Okay, that's an exponent rule, so don't forget that. Okay, so with the a's in this case, a to the 7th times a to the 6th, that's going to be a to the power of 13. 7 plus 6 is 13. And then for the b's, same thing. We have b to the power 4, b to the power 2. So we add those together, and that's going to be 4 plus 2, which is going to be 6. So right now we have the cube root of -108, a to the power 13, b to the power 6. So now the next thing we'll do is we'll do a factor tree for that -108. But of course, remember that because it's a negative inside the cube root, we can go ahead and take out that negative. So let's go ahead and do that now. So we have negative cube root of 108, and then a to the power 13, b to the power 6. So now the next thing we'll do, like I said, is do that factor tree for 108. So we'll just come over here and do the factor tree for 108. Remember, looking for a group of 3 numbers. So let's see here. Let's do 108 with, we can do, we'll just do 3 and 36 because we just did that. So 3 times 36. For 36, I know that goes in, that 3 goes into that. So 3 times 12. For 12, we could do 3 times 4. And then for 4, it's going to be 2 times 2. And I'll go ahead and put it, but I didn't do it on my notes. The reason why, of course, because it's 2 times 2, or 2 and 2, that's just 2 2s. It's not a group of 3 numbers. So, but I've already done it, so it's okay. But I do have a group of 3s. I do have 3 3s here. So therefore, I'm going to circle the group of 3s. So here we go. So there's those. And then I'm gonna put a box around the 2 and this 2. Okay. So right now, what we have here is we're going to have, if I come back over to the problem, I have my cube root. I'm going to have, let's see, we'll have 2 times 2 on the inside. Okay, so I'll put that on the inside. And then I have a group of threes. So that's just 1, 3. I already had a negative outside. So basically, it's going to be -3. Remember, I'm going to move it all the way over a little bit because we have variables to deal with as well. So now let's deal with the variables. So now we have a to the 13th and b to the 6th on the inside. So what that basically means is that we're going to start off by taking a to the 13th. And remember what that means is that we'll take the exponent here, 13, and divide it by the index, which is 3. And we ask ourselves how many times does 3 go into 13? That goes in 4 times with the remainder of 1, because 3 times 4 is 12. So you have 1 left over to get to 13. Then for b to the power of 6, that means we're going to take 6 and divide it by 3. So that means we're going to have 2 with the remainder of 0, because 3 goes into 6 twice, no remainder. So now what that means is that we're going to get the a, which we got to be 4 with the remainder of 1, means we're going to put a to the power of 4 on the outside, and then with the remainder of 1, we're going to put that a to the power of 1 on the inside. Remember, because it's 1, we don't have to write the exponent. Then for b to the power of 6, we got it to be 2 with the remainder of 0. That means we got b squared on the outside, and then since the remainder is 0, we have no b's to put on the inside. The last thing we'll do, of course, is just simplify what we can. We had 2 times 2, of course, on the inside. So basically, that means all we got to do is multiply 2 times 2, which is going to be 4. So basically, we rewrite the answer like this. It's going to be -3 a to the power of 4, b to the power of 2, and then we write the cube root of 2 times 2, which is 4, and then just the a right there. Okay? And so therefore, that is our solution to this problem. All right, so now we're on to our next problem, which is basically like the second part of multiplying, because we have what's called a binomial times a binomial. Okay, remember a binomial means you have 2 terms. You have 2 terms. So what we're going to do is we're going to multiply these binomials together, and the way we multiply, binomials together is, as we've discussed before, is using either the box method or FOIL. Okay, and so and I'm going to use FOIL because we've been using that lately. So FOIL, remember, is first, out, in, and last. Okay, and I guess I should say outside and inside. Okay, so how does that work? Well, we're going to start with the first. So that means we're multiplying the first 2 terms. So that means we're multiplying the 8 and the 3. See, those are both the first terms. So we're going to do 8 times 3. So 8 times 3, I'm just going to put that right here. Then we'll do the outside, which is basically the 8 and the negative square root of 10. So basically, that's going to be a -8 square root of 10. Okay. Then we'll do the inside, which is basically this negative square root of 10 and this 3. So that's going to be a minus or negative 3 square root of 10. And then we have the last, which is basically the negative square root of 10 and the negative square root of 10. Well, remember, a negative times a negative is a positive. So it'll be plus, and then it'll be the square root of 10 times the square root of 10. Okay? So that's what we got. All right, so all we've done so far is just showing you that we are multiplying the proper terms. Now, the next thing we'll do is try to simplify this. So we have, of course, 8 times 3 at the beginning. So 8 times 3 is 24. Then and then I'm just going to drop down the next parts, -8 squared root of 10, -3 squared root of 10. Then we have here plus the square root of 10 times square root of 10. Well, 10 times 10, remember, is 100. So it's going to be the square root of 100. Okay? All right, so it'll be square root of 100. So now all we have to do at this point is simplify the square root of 100, because we can, because the square root of 100 is just going to be 10. So I'm going to rewrite this now as 24 minus 8 square root of 10 minus 3 square root of 10 plus 10. Okay, and now what we can do is you'll notice that we have just regular numbers, the 24 and the plus 10. We also have some radicals, minus 8 square root of 10 and minus 3 square root of 10. And you can do a factor tree for 10 if you like, but it's going to be a waste of time, to be honest with you, because, if you do 10, it's just going to be 2 times 5, and there's no pairs at all. So, but since they both have a square root of 10 in their term, we can combine them, okay? We're just going to go back to adding and subtracting basically at this point. So what we're going to basically do here is, as I look at my notes here, is that we're going to take the 24 and the 10. So we're going to take 24 plus 10, okay? We're going to put those together, and we're going to put the radicals together, which are negative 8 square root of 10 and negative 3 square root of 10. Okay, so we're just going to add those together. So we're going to have 24 plus 10. So 24 plus 10 is going to be 34. So we got 34. And then we have plus negative 8 square root of 10 minus 3 square root of 10. So that's going to give me, well, negative 8 minus 3 is basically going to be negative 11. So it'll be negative 11 square root of 10, because remember the last part does not change. And then finally, not really too much to do after this, except just take that plus sign out and just rewrite it as 34 minus 11 square root of 10. Okay, and there's your answer. All right, so here's our next problem. We're almost there. We're almost there at the end. Okay, so we have a square root of 3k that's outside of a set of parentheses, which has a binomial in it. So what we're going to do is we're basically going to distribute the square root of 3k into this parentheses. And we could do that, remember, because all of the radicals have the same index. The index is going to be 2. Okay, so let's just go and distribute. So we're going to basically take the square root of 3k, multiply that to the square root of 12k. So basically it's going to look like this: the square root of 3k times 12k. All right, that takes care of that. Minus, and then we have a 2 here, but we don't have a 2 or don't have any number in front. So basically this will be minus 2. And then we're just going to multiply the insides, which is 3k times 15k squared. Okay. All right, so now we're ready to try to simplify this. So we have 3k times 12k on the inside of the first part. So basically what that will be is we'll have the square root of 3 times 12, which is going to be 36. And then we have the k times k. Well, basically that's k to the 1 times k to the 1. Remember, when you multiply with exponents, you're going to add. So therefore, it's going to be k to the power 2. So that takes care of that. Then we got minus 2. And then for the numbers on the inside of this one, we have 3 times 15. So 3 times 15 is going to be 45. And then we have a k to the power 1 times k to the power 2. Remember, add the exponents. So it's going to be k to the power 3. All right, so now this is where we are. And so now at this point, we're going to try to simplify our radicals. So first, we have the square root of 36k squared. Well, you should know, I hope, that the square root of 36 is 6. So we're going to have that 6 that's going to be on the outside. Well, we'll write that in just a moment. But you know that we also have k squared. So let me go ahead and just deal with that real quick. So k squared means we're going to take that exponent 2 and divide it by the index, which is also 2. So 2 goes into 2 once with a remainder of 0. Therefore, we're going to write this as the following. We're just going to take the square root of 36. Square root of 36, of course, is just 6. So we'll just write, let's see here. Yeah. So this will just become 6. And then 1 remainder of 0 is k. And then there's nothing to write because square root of 36 was easily square rooted. Okay, it's a perfect square root. 36 perfect square root. So right now, the square root of 36k squared becomes 6k. Okay, that's what it becomes. Now, the next part, we have minus 2, and then we have the square root of something. Okay, well, we're going to take the 45, and we're going to do a factor tree for that. So I'll just come over here and do that. So for 45, we're going to have, let's see, 3 times 15. 15 is going to be 3 times 5. And because the index is 2, that means we can find a group or a pair. So that pair is a pair of 3s with a 5 on the inside. So right now we know that the 5 is going to go on the inside of the square root. We also know that the 3 is going to go outside with this 2. So we're going to put a 3 right outside of the 2. We also have a variable to deal with, k to the power of 3. So k to the power of 3 basically means we're going to have, k to the power of 3. So therefore, it's going to look like we're going to divide 3, the exponent, by 2, the index. That's going to leave you with 1 with a remainder of 1, okay? Because it goes in once with a remainder of 1. So that means that we have, with it going in one time, we're going to put the k on the outside, okay, like that. And then we're going to put a k on the inside because it was a remainder of 1, okay? Then the last thing we'll need to do is just, do a little simplifying. So basically, we'll just bring down the 6k that we got from the beginning. So yeah, we're going to bring down the 6k. Here we go. And we have minus, and then we have 2 times 3k, which is going to be 6k. And then we have the square root of 5k. At this point, there's really nothing more we can do because the first term, the 6k, does not have a radical. Okay, so even though they both have 6k, it's that the 6k does not have a radical first. So therefore, we going to go ahead and just box the answer in, and then that's it. That's our answer. All right, so here we go with our final question, number 9. And we have a rectangle with these dimensions. And what was asked, and I did not write the question, but what was asked was to find the area and perimeter. Okay, find the area and perimeter of this rectangle. Okay. Now, since we just got off of doing multiplying, let's go ahead and do the area first. So recall that the area of a rectangle, remember, is going to be length times width, okay? Area is length times width. So basically what we'll do is we'll replace the length and the width with, parentheses with those terms. So we have A equals the length, which is 4 minus square root of 6, okay? And then the width is 7 square root of 6, and then plus 3, okay? So we're going to do just like we did on our earlier example. We're just going to FOIL it, okay? And then, simplify it to find our answer for the area. So to do that, we're going to start doing that right now. So we got area equals. So we're going to have 4 times 7 square root of 6. And so 4 times 7 is 28. So we're going to have 28 and then square root of 6, okay? Then the next thing we'll have is 4 times positive 3. So 4 times positive 3 is going to be a positive 12. So we can write that right there. Okay. Then for the next part, we have negative square root of 6 times 7 square root of 6. So basically, that's going to be a negative. It's going to be a 7 on the outside. And then it's 6 times 6 on the inside. So it's going to be 36 on the inside. Then we have negative square root of 6 times positive 3. So that means the 3 is on the outside. So we actually it's going to be a negative, right? Because a negative times a positive is a negative. So it's going to be negative. As soon as I can find my undo here. I don't know where my undo is. There it is. Okay. Can I undo it? I guess not. Okay. All right. It's thinking. Okay. So I'll just erase it. All right. So that's going to give us, like I said, it's going to give us negative or minus 3 square root of 6. Okay. All right. So now the next thing we'll do is we'll try to simplify this as far as we can. So we do see that we have 2 square roots of 6s. You know that square root of 6 cannot be simplified because the only way to get 6 or another way to get 6 is 2 times 3, and that's not going to be any pairs. But we do have a 36 inside the square root, and as we talked about before, 36 is a perfect square, can be square rooted. It's a perfect square root, so therefore we can rewrite the problem like this. It's going to be area equals 28 square root of 6 plus 12, and then we have minus 7 parentheses 6, okay? Because the square root of 36 is 6. And then we still have minus 3 square root of 6, okay? So now the next thing we'll do is we're going to, let's see here. Did I do something wrong here? I don't think I did. Although I do have, oh, I see. I have something else here. Okay. I'm going to keep it as it is. Okay. All right. I did not write something correctly, but that's okay. I'm gonna I've already gone through this problem. There's no point of going any further. Now, what we're gonna do at this point now is we're just going to combine like terms. So we have area equals, we have 28 square root of 6 and negative 3 square root of 6. So we're gonna just combine those together. So I will, yeah, let's outline these. So it's going to be 25 square root of 6, okay? Then we have plus 12, and then minus 7 times 6 is minus 42, okay? We can combine 12 and 42, 12 and negative 42, I should say. And so that's going to leave you with 25 square root of 6, and then it's going to be 12 minus 42, it's going to be minus 30, okay? And just so I can, I'm going to go ahead and just reorganize it, and you'll find out maybe later on why I do it this way, but area will equal to negative 30 plus 25 square root of 6. You always want to keep the radical on the end. I mean, that's basically how it works, okay? So we have found the area, and we found the area, okay? So now we're going to find the perimeter. So remember the perimeter, and let's see if I can get this shrunk a little bit. See if I can change my settings here. Okay. Let's see, is that going to work? Yeah, that'll work. Okay, so we found the area. So now the next thing we'll do is we'll find the perimeter. And so to find the perimeter, what we'll do is perimeter, remember, is 2 times the length plus 2 times the width. So basically what that means is that the perimeter is going to be 2 parentheses 4 minus square root of 6, that's the length, plus 2 parentheses 7 square root of 6 plus 3. Okay, so what we're going to do basically is we're going to just multiply the 2 into the first parentheses. So basically what that gives us is we have perimeter equals 2 times 4, which is 8. Okay, so it's going to be 8, and then it's going to be 2 times this, so it's going to be minus 2 square root of 6. Okay, then we're going to do the same thing for the other parentheses. So we're going to do 2 times 7 square root of 6. So that's going to be plus 14 square root of 6. And then we have 2 times 3, which is going to be plus 6. Okay? I like it this way anyway. So, and then the last thing we'll do is to combine like terms. So we do have the regular numbers. So we have regular 8 and 6. So if I add 8 and 6 together, that's going to be 14. So it'll be 14 right there. And then the other ones are just regular negative 2 squared root of 6 and 14 squared root of 6. So we just add those together. So negative 2 plus 14 is going to be 12 positive. So it'll be plus 12 square root of 6. And this would be the perimeter of this problem. All right, thanks so much for watching this video. I hope you learned something from this, and I'm going to be looking forward to seeing what kind of work you will do with problems like this. Um, I would imagine soon that I will have another video. But in the meantime, thank you for watching, and please feel free to like and comment if you need to. Otherwise, um, be careful out there, stay safe, and stay warm at this point because we're getting some cold weather now here in December 1st. And but in the meantime, take care, and we'll see you again soon.